Topics covered in application of derivatives. Welcome to this session on the application of derivatives. In this module, we will explore how the theoretical concepts of calculus are used to solve practical problems. First, we will cover the rate of change of quantities. Here, you will learn how to calculate the instantaneous rate at which one quantity changes relative to another. For instance, we can determine exactly how the volume of a sphere changes as its radius increases. Next, we will examine increasing and decreasing functions. By utilizing the first derivative, we can determine the specific intervals over which a function is rising or falling, which allows us to understand the general behavior of a mathematical model. Finally, we will discuss maxima and minima. We will apply the first and second derivative tests to locate the peak, known as the maximum, and the trough, known as the minimum, of a function. This process is essential for solving optimization problems, where the goal is to find the most efficient solution. Once we have a grasp of these three core concepts, we will move on to see how they are applied across various professional fields in the next slide. Real-world applications of derivatives. Now that we have covered the theoretical tools, such as rates of change and optimization, let's look at how these concepts are actually applied in the real world. In physics and engineering, derivatives are fundamental. For example, they allow us to derive velocity and acceleration from a position function. Engineers also rely on them to analyze stress and strain on materials, ensuring that structures are designed for maximum stability. Moving into economics and business, we encounter marginal analysis. This is essentially the use of derivatives to calculate marginal cost and marginal revenue, which helps businesses determine the precise production levels needed to maximize profit and minimize expenses. In the fields of biology and medicine, derivatives are used to model the rate of population growth, track the spread of epidemics, and determine how quickly a drug is absorbed into the bloodstream. Similarly, in chemistry, they are used to measure the rate of chemical reactions by analyzing how the concentration of substances changes over time. In essence, the application of derivatives provides the mathematical framework necessary to analyze change and achieve efficiency. This makes it an indispensable tool for any student pursuing a career in STEM or the social sciences.